Hello, my name is Andrew Boyd, and I am the project manager for the City of Yelm Water Tower Structures team. My assistant project manager is Kai, and our designer drafters are John and Raiden. We were given this project by the City of Yelm because they projected a population increase over the next 10 years that would require an increase in water storage capacity in their city. So our goal is to design a water reservoir with a capacity of 1.5 million gallons on the 1.3 acre lot that they bought in the southeast corner.
My name is John Gonzalez. I am one of the drafters / designers for the project. For the project location, the address and parcel number are shown on the slide. As for the site condition, to the north end of the site is the entrance and what appears to be functional fire hydrant. Down to the southeast of the site, there's a utility box attached to a pole. However, it is unclear whether or not it is functional. And the concrete slab that was left over from the previous building is still there and will most likely need to be replaced. There is asphalt on the entrance side going in to about halfway down the length of the lot.
In order to establish the design criteria for the project, we looked at the different building codes, manuals, and standards and guidelines in order to find the requirements for designing a water reservoir. Feel free to pause the video to read the regulations, codes, and standards that we have found to have an application to our design process.
In order to determine a final structure to design, our group came up with an alternatives analysis based on a few factors and several options for our design. The parameters that we decided on were the longevity of the structure, the amount of material, the aesthetic, the ease of construction, the cost of the materials, the maintenance, whether or not the alternative met the demand, and the operating costs. Our options were the do-nothing alternative, a steel standpipe reservoir, a concrete standpipe reservoir, an underground tank, and a steel tower. Most of them were weighted approximately the same, except for the demand, whether or not the demand was met, because if we hadn't ranked it as 15, the do-nothing alternative would have been the best solution. And obviously, if it doesn't meet the demand, then it shouldn't be the best alternative. So we decided that was not going to go. So all of them were ranked from 1 to 5, 5 being the best, 1 being the worst. And you can see the scores in the tables, and the steel standpipe ended up being the best option when considering all factors.
Understanding the risks of any project is an important step in design considerations. We have identified a list of probable risks and assigned a risk value and probability score. The list has been organized in descending order from highest risk value and highest probability to lowest risk value and lowest probability. We have identified that the highest risk with the highest probability to be the failure of the structure. With the exception of the labor strikes, we will be using the resources that we have identified in the design criteria and in the additional resources in order to design for the identified risks.
So this is a rough concept for the project schedule. We have completed the project management plan and the design criteria, and we are currently at the engineering advisory board presentation and 30% submittal, which will be in the next week or so. And that will send us into Christmas break, which we will come back for the second semester for the 60%, 90%, and 100% presentations and submittals.
Hello, my name is Raiden Oweki, and I'm one of the designers and drafters for the City of Yelm Structures team. And regarding cost estimates, our team has been provided a template that will assist us in calculating and keeping track of the cost estimates as we make progress in our project. And at the 30% stage and 75% contingency, We are still collecting the data needed to develop a rough cost estimate, but our cost estimate will continue to update as we move towards the 60% and 100% stages of our project.
These additional resources will be used more as we get more information the further into the project we go. Most of these we have looked through before. However, the American Water Works Association textbooks we have not had a chance yet to look into.
So the next steps is to get our calculation package ready. So for that, we need our dimensions so that we can start our designing and drafting. We also need our hydraulics analysis and assessment. And we also need to incorporate sustainability into our project. And as we move towards 60, 90, and 100% of our design, we will continue to develop our cost estimates.